Professor Zoltan Rasch is a theoretical physicist from Hungary. He works in the Eötvös University, Budapest. He is a research professor as well as a member of the Hungarian Academy of Sciences. Professor Rasch, being a physicist, could you please explain how you get involved in climatology?
Well, my basic research is in statistical physics, in equilibrium and non-equilibrium phase transitions, precipitation, and this type of topics, which are closely related to climate problems. If we just think about clouds, how the clouds are formed. But actually I got involved not because of this, but because about 10-12 years ago there was much hype in the media, and with our friends we started to check out a little bit that is it true what is said in the media. And we found out that quite often those were just statements which were coming out of blue. Of course, when we talked to climatologists, they said that this is not how you have to understand. You have to understand as we say it, but the media distorts it quite often. Okay, so this lasted for a while, and we started to follow some simple time series of temperature, various data about the winds in Europe and so on, and we found out that most of the time whatever appears about climate, it is distorted a little bit even by the climatologist. And we felt somehow that there is a political overtone in all these problems, and somehow the activists took over the field. And we think that this is slightly dangerous, because climate has been handled by activists before. If we take, for example, the Little Ice Age, which started around the 16th century or 15th, 16th century in Europe and lasted almost 500 years. This was a period when the temperature didn't go very much down, but actually what happened is that the seasons, the cold season, expanded a little bit. So, for example, in May there was a 5-day freezing, which means that whatever was sown was frozen and disappeared. And in September already, for example, which is very unusual in Europe, most part of Europe, the snow was falling down. And this means that people couldn't eat because they couldn't produce anything in the very short season, warm season. And of course this made nervous the people, and they were looking for somebody to blame, something to blame. And at the beginning it was just like now, it is the whole humanity to blame, so the priest would stand out and say that you were sinning and this is what you get for sinning. Okay, and but they couldn't do too much with this general accusation, and at one point the people wanted real accusations against somebody. So what happened is that they were choosing somebody, a woman from the end of the village, and they said that this is the woman who is a witch, and he is causing all our troubles, the weather maker witch. The trouble was that this couldn't go very far with these accusations, because in the Bible it is said that the weather is made by the God. Okay, so when the people brought the woman to the nobleman that she should be burnt, then he sent it to the priest, and the priest was telling that, well, this is not my job, or it cannot be done actually, because it is written differently in the Bible. So after many years, these discussions all over philosophy and in the usual media at that time, they persuaded the Pope to issue a bulletin in which it was agreed that from now on, weather making is a sin, the witches can be burnt for that. And then slowly it started, and during the period from 1500 to 1800, there were about, well, there are various estimates, but about 100,000 to 1 million witches were burned in Europe. And of course, this shows that somehow the frustration leads to activism, and the activism leads to tragedy. In some sense, all this was for none. Clearly, we know that it is not the witches who made the bad weather, but crazy people are always around. And for example, at the time there was a kind of philosopher monk who was suggesting that, well, we are burning somehow randomly these witches, but we should somehow scientifically burn the right number of witches in order that there would be the right weather. So in this sense, you can see some analogies that how the people nowadays as well trying to find the scapegoats, trying to change something which is extremely hard to change, and you don't know what will be the effect of the change. So I think it is in some sense the responsibility of scientists who are close to the field of climatology to really make some checks whether everything is going as it should be in a normal science. Of course, in science, there are sometimes questions which cannot be answered at the given level. When to bring an example from mechanics, Newton, who was writing down first the equations of mechanics, and basically he explained all the planetary motions. And this was a big achievement, and everybody knew about it at the time. And one of the bishops asked Newton that, well, but can you also explain the regularity of the distance in the planetary distance from the sun? Because there is a regularity which is called the so-called Titius-Bode law. And Newton said that, well, I cannot explain it because this is initial condition. This is given by the God. Once he put there at the appropriate places the planets, they are going according to mechanics. That is what my theory explains, but I cannot explain something that how they were put there. Now, of course, nowadays already there are some theories which can explain these laws, give arguments that how they can, even if the initial conditions were completely different, they are leading to the same regularity in the positions of the planets. Now, at Newton time, nobody, if you gathered all the best minds of the world, they couldn't have solved the problem because it was not within the realm of the given science. Now, you can say something similar in the about climatology, in the sense that there is a science which involves very many very complicated issues, starting from the physical processes to the mathematical handling on the computer of the equations to the enormous databases with which you want to somehow a consistent picture. And maybe at this moment, simply these equations are too complicated, or we don't know a large number of those equations which should go into the story. So clearly there may be the possibility that at this moment you are not able to predict the future from the present knowledge. Okay, so this is why I think that this is a serious issue of climatology. I would like to emphasize that climatology, of course, is a serious science, and the people there are making lots of effort to understand things, but the issues are very complicated, and sometimes because there are uncertainties in the answers, politics takes over. Okay. Interpreting the issues.
Okay, from the theoretical physicist point of view, could you explain what are the major challenges the climatology subject is facing today?
Well, of course, if you would like to solve the problem, the challenge would be to predict what will happen in the next 50 years or the next 100 years. Though, well, this is extremely hard. This is this is a scientific problem in which you can see somehow two extremes. One extreme is this short time limit. Well, meteorological predictions nowadays can be trusted for, let's say, for the next 5 days or something like that. And it is the same model which is giving you this very short time behavior, but after 5 years it disappears. You cannot trust really the present models. Now, suddenly the climatologists use the same models, basically it is the same, and running on a larger scale, and they claim that, well, because over sufficiently long time there is an averaging process. Just in statistical physics, complicated processes are averaging out, and this is why their model can predict what's happening in the intermediate times, let's say, of 50 years or 100 years. In the same way as if we take this the air in this room, it consists an enormous number of molecules. If you would like to solve the Newton's equations for this, you would go nowhere. You wouldn't predict anything good. But if you average all the motions, then you can predict all the thermodynamic laws and the properties of this gas in this room. The problem with the climatology models that if you try to ask the climate models that what will happen on the long run, then they cannot again explain what's happening on the scale of 10,000, 5,000, 10,000, 50,000 years. Okay, because that is the issue of the so-called ice ages, of glaciations, that with a period of the order of 100,000 years, during the last 800,000 years, we are always spending about 80, 90,000 years in a very cold period of the order of 8 degrees cooler than at present. And then we are living our good life during this 10, 15,000 years, which we are at this moment. And of course, one would like to know what will cause these ice ages, okay? And what will cause jumps of temperature of the order of 8 degrees, let's say. And this is an issue which should be solved. This is a scientific issue, and lots of people worked on it, and there are about 10 different theories of ice ages, which all roughly explain that something happens in every 100,000 years, but all these theories are starting with different premises, have different effects which are causing the big changes, and somehow they don't have any consequences which could be checked in whatever way, what we are used to in physics, that once you have a theory, you are testing in some way, either predicting something in the future or predicting something in the past which nobody has seen before, but then you are looking for that phenomena. And what I'm trying to say that this is what, even as a physicist, I was interested enough, and during this last 10 years, I went through the theories of ice ages, and the conclusion, if you go through, is that there are many theories, all of them are saying that something is there, but if you can arrive at the same results from very different starting point and from very different using very different effects, then I would say that none of these theories are working. So we don't have at this moment an understanding of why does the Earth go into this ice age type behavior climatologically. So I would say that all the models, whatever the models are, have a basic problem. The basic problem is that if I look at short time, after a while the model becomes, after 5 days or something like that, becomes bad. If I look at long time, the model is again becoming bad on the scale of several thousand years. And then the claim of the climatology society or community is that the model works in between, in the middle part. And as far as physics is concerned, we do not have such theories which would break down at small time, large time, but they are good in the middle. Okay, so this is why I think that the predictions going for, let's say, 50 years or 100 years are basically cannot be trusted. This is my belief, of course, and this is a difference with many climatologists. But of course, in order to go in a very difficult problem, you have to trust that you will arrive at something. So otherwise, you can't really go very far. Okay, so this is why how I think that.
Yeah. How dependable our data are on which the scientific community is working on?
Well, of course, there are again these different time scales are coming in, and you have some knowledge about the temperature variations, let's say the drilling in the ice in the Antarctic or in the Greenland, and it is quite good. It is giving the accurate reading roughly of the temperature on a time scale of, if we go back, let's say 100,000 years, then it is of the order of 100, 200, 500 years, the accuracy of the determination of what temperature we are looking at, what time we are looking at in the past. And if we come closer now, let's say we are going at the much contested last 1,000-year problem, then there are many different ways of determining the temperature, tree rings, again the sedimentations and various geological methods, but time to time you see that statistics and the analysis is coming into the picture, and it makes it uncertain what we see. What one can hope that the situation is becoming better is that since 1979 we have a satellite observation of the temperature of the Earth, satellite observation of the coverage of the by clouds of the Earth, and there is lots of data which is coming in, and this is what I'm trying to say when I'm saying that the handling of databases is a very important part of climatology nowadays, because you have enormous amount of data coming in, and you have to somehow incorporate it or make it agree with the models what they are trying to develop. Okay, so there is problems, of course, with the data. If you come back, even if you say that the present situation with the satellites, you will see that the satellites have fluctuations. They are sometimes sinking in the in the atmosphere, or because of the some problems with them, and well, you have to work on it. I think, but it is getting, I think, better and better. Of course, if you look at the usual gathering of statistics, let's say the measurements of the temperature at various meteorological stations, there also nowadays you have already automatized systems. But if we go back, let's say 50 years in time, then only the caretaker of the equipment was reading the equipments, and sometimes they didn't read, they just wrote in some numbers, because you can see there is a so-called weekend effect in the old data, that if you look at the statistics of the weekends readings, it is different than the weekdays readings. So clearly there are small uncertainties in the story, but in general I think the problem is that the Earth wasn't covered earlier more or less evenly. Even nowadays there are the satellite data and there are lots of stations on the ground, but there are much less in the oceans, which are, of course, you have to recognize that is the more important part, both because the heat capacity of the oceans, the intake of energy or outgoing energy is much larger than in the ground. So that is still the problem.
Okay, from the layman point of view, is it worth to believe this scientific community on this subject about predictions?
Layman is in hard situation, because the layman is nowadays bombarded by by these messages which try to convey that you are sinning, yes, and because of you there is the increasing temperature. I believe that that part of the story, that there is an increasing CO2 concentration, carbon dioxide concentration in the air, that is partly coming from the humans. And the question, does this cause the increase of the temperature which is observed in the last 150 years of the order of 0.7 degrees? Is it what is causing it? Because then, well, it is still a question whether it is bad or not if there is a 0.7 degrees of temperature change, because nobody says at this moment, I believe, that the basic inhabitability of Earth has changed much because of this 0.7 degrees of Celsius. But of course, there is the chance that it is coming from the human behavior. And then you have to ask that what can you do, and the layman is doing every kind of, well, at least they are trying to make the layman to do sometimes crazy things. But I would say that at this moment, the layman can say that there is no firm evidence that I am the sinner, okay? Because the chain of argument which is coming to this sin is going so that there is an increase of CO2, and this is probably cars and every industry, and then because of this increase of CO2 there is a slight warming. If we just take that what is the greenhouse effect of the carbon dioxide, then that is a small amount of change in the temperature. That is not the important part. The important part is that people in these models assume that there is a positive feedback in connection with the clouds, okay? Because if there is a little bit of increase of temperature, there is a little bit of increase of evaporation, there is a little bit of increase of clouds, but the clouds then are assumed to carry a much larger greenhouse effect, and this much larger greenhouse effect is of the order of 10 compared to the CO2. So this would be really a serious effect. But the problem with this is that the clouds also have an albedo effect. If I just have nothing around, I just evaporate liquid and I have a cloud, then there are two things which is occurring. If you look from above, from a plane, then it is white. Yes, clearly it is reflecting, so the albedo increased. So in this sense, less energy is coming on the Earth, so this is a cooling effect. The other one is that, of course, it is water vapor, it is a greenhouse effect, and it has its own greenhouse contribution. Now, the question is, what is the difference of these two effects? And at this moment, nobody can really tell what is the situation, because if the cloud is formed low, at not very high distances, let's say 500 meters, then it is known, actually these are satellite measurements, it is known that it has the albedo effect is winning. So it is actually cooling the Earth. But if you have a cloud at 10,000 meter high, a cirrus cloud, then you will have a greenhouse effect overwhelming the albedo effect. So, and what's happening when you really increase the CO2, which one will win on the overall scale, nobody can predict at this moment. So this is the crucial matter which, and here I think the physicists have a very constructive approach. At CERN in Geneva, they use these bubble chambers which are used for particle physics. They use it for studying how the precipitation occurs and what kind of distribution of particles occurs, because this distribution will determine what type of albedo a cloud has and what type of greenhouse effect the cloud has. So within 5, let's say, or 10 years, partly the physicists will contribute to this debate by at least giving some data, experimental data, as you can imagine, is very hard to come by, where really you control something in climate and then you are looking at the effect. So they will have an experiment where they can control parameters and can tell what kind of clouds are forming. Okay, so this will be very important, I think, and I think at that time it will be clearer what is the how much of the sin of increasing the CO2 will increase the, well, will lead to large changes in temperature. But really, if you look at the historical temperature record, then you will see that if we go back a few million years, then the temperature of the Earth was about 8 degrees higher. If we go back to the dinosaurs 60 years ago, it was about 10 degrees higher. Well, the life was thriving on the Earth. So it is always a question that aren't we a little bit arrogant when we say that this is the only temperature what we selected and this is where we can live and at no other temperature.
Okay, this subject climatology, you know, is an emerging subject in the universities nowadays. So, much physics is involved in this science. Can we associate a physics course together with the climatology in universities?
Yeah, I think definitely, and this would be important. As far as I can see, for example, in Budapest, who are doing climatology in the meteorology department, they have very little physics education. And clearly the basic is physics because, well, you have the convection of evaporation and there with the cloud formation. All these are physical processes. Well, the simplest calculation to calculate the temperature of the Earth, what can be expected is just to say that there is a given energy coming to the Earth, and then the Earth re-radiates this energy as a black body, and this already gives quite good result for the temperature of the Earth. And then, of course, there are the corrections. But what I am saying is that all the processes are physical processes. You have the energy flow, the currents in the sea. These are all hydrodynamical. The atmospheric is the gas form of the matter, how it behaves. So clearly, people who are knowing all these fields, this means that you have to know thermodynamics, you have to know hydrodynamics very well, you have to know the statistical laws, statistical physics. These are important subjects and this should be compulsory. Of course, nowadays climatology is a little bit compartmentalized because, as I was saying before, there are the people, physicists who are going over, who know the physics laws. Then there are the mathematicians who are doing the implementation of whatever the physicists are doing or whatever they are thinking about the problem. And then, of course, there are the programmers, because this is, since the programs are enormous, so you have to be a specialist and you have to know really the programming and the details and the tricks and so on. This is a trade as well. And then the fourth one is again the data handling. Data handling is not trivial nowadays. Most of the people think that, well, I have a time series. But when you have millions and millions of time series and the bits are going into the, I don't know how many, 10 to the 12 or not, no, 10 to the 18 even, then you have problems, okay, which have to be handled. And, well, this has to be taught as well, probably taught also to physicists as well.
Professor Ash, you shared a lot of ideas and insight about this subject. So, I would like to thank you very much for this.
Okay. It was a pleasure to come here and welcome to you.